All right, now in this video right here, still talking about trig stuff, but we're specifically going to talk about sine and cosine. All right, there's a specific reason why it's called cosine. All right, there's a relationship. So given this triangle on the right, what's the relationship of the measure of angle B and the measure of angle A? All right, so this is just some random right triangle. I think I probably just Googled right triangle and copied and pasted this from the internet. We don't know much about this right triangle, except we know this is a 90-degree angle. That's 90 degrees. Well, hold up. Measure of angle A plus the measure of angle B plus the measure of angle C. Something I know about all triangles, they add up to 180 degrees. Well, I know measure of angle C is 90 degrees because it's a right angle. So if I plug that in, and then I'm going to subtract 90 degrees from both sides, well, I don't know specifics, but I know with 100% certainty that measure of angle A plus the measure of angle B equals 90 degrees. We add up those two angles together. Again, I have no freaking clue what this exact angle measure is. I do not know. I have no freaking clue what this angle measure is. I do not know. However, I do know if you add it together, they add up to 90 degrees. All right? So what is the relationship when we call two angles? We have not talked about this in a long time, but they are complementary. All right, sine and cosines, sine is called sine. Cosine is called cosine because it's complementary to sine. Complementary to sine, that's how we get the name cosine. All right, now for fun, we're going to write the trig ratios for sine of angle A and the cosine of angle B. And just to make this a little easier, let's just we'll pick random letters. Let's just call this lowercase b, lowercase a, lowercase c. Very random. But nonetheless, focusing on sine of angle A, well, the opposite is lowercase a and the hypotenuse is c. Let me zoom in a little bit, make that a little smaller. Cosine of angle A, well, the adjacent side was lowercase b, hypotenuse was c, and then tangent of A is opposite. Okay, that's what we get right there. Now, I'm going to do this in a different order, but now cosine of angle B, let's do cosine first. Let's compare cosine and sine A. All right.
Craig Loman, can you come down to the main office, please?
Hopefully they find Craig Loman. But nonetheless, cosine of angle B, adjacent to angle B, is side A, and then the hypotenuse is C. So realize how if you pick the different angles, they equal each other. And this is something you might have been noticing. The sine of angle B is now lowercase b over lowercase c. So those are the same. And then the tangent of angle B, well, opposite is lowercase b and lowercase a. This is a case where they do not equal each other. Those orders get swapped. So this is why it's the sine and cosine relationship, all right? So what do we notice? We know that sine of angle A is always going to equal cosine of angle B. Even vice versa, or mixing it up, you could say the sine of angle B will equal the cosine of angle A. This is true for all right triangles. Bally that. All right, cosine is complementary to sine. You better believe it. All right, so some quirky follow-up problems. Again, I steal these problems from all over the world. Sometimes I like to talk about some funky things, but right triangle shown below. The sine of angle F is 0.53. All right, so we got angle F. That angle over there, that's opposite, that's hypotenuse. Well, I know that the sine of angle F is equal to 0.53. All right, that's kind of a quirky way to express it. We haven't really talked about it in that manner. Well, it's telling me the cosine. What's the cosine of angle H? Well, remember now that's opposite. Now that's adjacent. That's still the hypotenuse. The cosine of angle H, using the fact above, it's just going to be 0.53. All right, so why did I pick this problem? I actually stole it from the air test. It's a very specific problem. It's this rule only that you have to know to be able to do it. But if you know this rule is incredibly easy. It's just equal. It's the same thing. The sine of angle F is the same as cosine of angle H. All right, and that makes this problem really easy. All right. Again, where did I steal this problem? I stole this from the air test. Angle A is the complement of angle B, which equation about the two angles must be true. Well, is this one right here. All right. And again, we literally wrote it out just in reverse up there. All right. The cosine of angle A equals the sine of angle B. All right. So that's it for this video. Stay tuned for more.